Welcome and hello. This is a support video for HEC-RAS, and in this video, I'm going to be checking and controlling the Courant number. So in this support video, I'm going to demonstrate the trade-off between a computational time interval, the runtime, and the Courant number using a 1D unsteady flow. All right, here we go. I've got the model up on the screen. This was sent to me from one of my viewers. I'm first going to run the model as it was sent to me that has particularly large Courant numbers. Then we're going to look at the results and then make a couple improvements to get those Courant numbers and hence the model stability under control. Okay, I'm going to go up to the run menu and then click on unsteady flow analysis. Now, right here, I've got a 30-year simulation, and the computational time interval is 6 hours. We're going to leave 6 hours right there as it is, but to make the simulation run faster, I'm just going to run 6 months worth of data right here instead of 30 years, because 6 months is enough to demonstrate what I'm going to talk about in this video. So I'm going to File, Save Plan, and then before I click Compute, if I want to track the Courant number in my results, what I want to do is go to the Options menu, Output Options. Now in this dialog box right here, this third tab, Computational Level Output Options, I can write these additional variables and I want to check on Courant in channel and Courant total. So this is going to keep track of the Courant number in the 1D model in the river. Channel is just for the main channel between the bank lines, and then total represents the total cross section to include the entire left and right overbanks as well. I want to, of course, check on this checkbox at the top, which will be for the entire simulation time. Time extents unless I want to specify just the starting and end date time right here. I'm going to leave this blank though. So this checkbox and then the two Courant number checkboxes is all I want to do. I'm going to click OK, File, Save, and then click on Compute. Okay, cool. That took 5 seconds, so that's good. I'm going to close and then look at my results, specifically the Courant number. To do that, I'm going to go up to View, and then I'm going to click on this option here for Unsteady Flow Spatial Plot Computation Interval. Now, the default variable it has here is the water surface elevation. So I'm going to uncheck that, but I'm going to check on the Courant channel and Courant total. Now, this particular spatial plot, what it does is it takes a single time period and it shows that particular variable or variables, the Courant number in our case, for every single cross section. So at the very top of the river reach, we have this cross section near river station 10,000, and then it flows downstream to river station 0. In fact, I can even click the play button to simulate the changing of the Courant number over the course of that 6-month duration of the simulation we just ran. Now, as you notice, we have Courant numbers that are extremely high. So this right here is 180, more or less. I'm just going to scan through and look for a maximum. But yeah, what we had there, about 180, is absurdly too large. We want that number to be less than 1. So one thing that we can most likely change to control and reduce the Courant number is to reduce the computational time interval. I'm going to go to Run, Unsteady Flow Analysis. Instead of 6 hours right here, I'm going to reduce this to something much smaller, such as 1 minute. So it's going to take a lot longer to run the model, but our Courant numbers will be less and the stability of the model will be much improved. So I'm going to go File and then Save Plan and Compute. So that ran, it finished, it took 2 minutes and 25 seconds. And now let's go ahead and take a look at the resulting Courant numbers from that simulation. As before, I'm going to go up to the View menu and then Unsteady Flow Spatial Plot. All right, so that is up on the screen now. Again, the default variable here is the water surface profile, which you can just toggle on and off whatever variables you want. These are the two variables, notice, for the Courant number that we checked on in that options box. So I'm going to toggle off this cross water surface elevation, and then boom, here are the values for Courant number in the main channel and then for the total cross section. You need to click this variable button to toggle it on and off. That's how that works. So let's go ahead and see what the maximum Courant number is. I'm just going to press the play button and we can kind of see it cycle through the different time steps. Of course, this is going to take too long because this is a 1 minute time step. So I'm just going to hit stop and then just kind of move my mouse cursor around. It looks like 0.5 is about the highest. Yeah, so we'll go ahead and say 0.5. Another way to look at this Courant number, instead of looking at every single cross-section's value at a given time step, we can do the opposite by going up to View, and then the other option here is Unsteady Flow Time Series Plot. What that's going to do is show us every time step, but one cross-section at a time. So that came up onto the screen here. And on the left panel, we get to decide which cross-section we want to look at. So this is the upstreammost cross-section near River Station 10,013. This is the next cross-section downstream, and then the next one down after that. It's taking a while to render because there's a lot of data. But this is the water surface profile we're looking at. Yep. So if I click on variables right here, and then toggle off water surface profile, but then toggle on the Courant number channel and the Courant number for the entire cross section. Boom, now we have that data. So I'll click the the button for variables. And again, we see that the Courant number is again maxing out at 0.31, it looks like, for this cross section. Let me load another cross section up. Okay, here's that. And again, we have two lines here. The red one, or it's red now, it was black a moment ago. That's for just the main channel. And then this line here, what's now selected as red, is for the entire cross section. The max here, I'm just seeing, again, 0.34, 0.33. So we'll just stick with 0.5, which is what we saw from the previous view. All right, so the last trial I want to run is to not specify the computation time interval. First time we ran 6 hours. The second time we ran 1 minute. But what I want to do is specify the maximum and minimum Courant number and then let HEC RAS determine what is the correct computation time interval to run for each time step. To do that, I'm going to go up to Options and then Computation Options and Tolerances. And then in this dialog box, I want to select this tab for Advanced Time Step Control. And instead of the first radio button, I want to select the next radio button down, Adjust Time Step based on Courant. Now you're going to probably see blank values in for these text boxes right here, but I've already entered the numbers I want. So the max Courant number is going to be 0.9. And if it tries to get above that, then it will just change the time step to something smaller. It will half the time step, which will reduce the Courant number. We're going to run one more simulation. I don't need to start it as low as 1 minute because it'll either double or half. I set it to 5 times or 12 times to double and half respectively. But let me go ahead and click OK to that. And then I'll just change this for an initial computation time interval to something more. Instead of 1 minute, maybe 10 minutes. We'll see what happens with that. All right, File, and then Save Plan, and then click on Compute. So I anticipate that this third trial is going to be somewhere between the first and second. The max Courant number will be between 0.5 and 180, and then the simulation runtime will be somewhere between 5 seconds and 145 seconds. So that's finishing up. Looks like it took a minute 46. So that's 106 seconds. All right. Let's take a look at the numbers, at the Courant numbers specifically. I'm going to go up to View, and then let's look at this first one, Unsteady Flow Spatial Plot. So again, this is every cross-section for an individual time step. This is the water surface elevation. We're not interested in that so much. So let's change that to, boom, remove that, toggle on Courant just for the main channel and Courant for the entire cross-section, and then click the variable button again. So it looks like it comes up to 0.5. I'm just going to click the play button. I'm going to search around for some larger numbers. Okay, looks like it gets up to about 0.8 right there. 0.6, 0.6 again, 0.7 more or less. So we'll say 0.8, but we know that it probably comes up to about 0.9, just based on the limits that we set. I'm just not checking every single time step. All right, so here is a quick summary table. What we did was we ran 3 different trials. The first trial used a computation time interval of 6 hours. It took about 5 seconds to run, and our maximum Courant number here was unacceptably large at 180. The second trial, we set the computation time interval to 1 minute. It took 145 seconds, and the max Courant number was about 0.5. And then our third and final trial that we ran was probably a best compromise between the two. Our Courant number maxed out at about 0.8 or 0.9, so the model was most likely stable, and the runtime for that was 106 seconds. So we saved ourselves about 39 seconds when running a 6-month simulation, But if we expand that to a 30-year simulation, which is what this model actually was, we'd be saving ourselves about maybe 45 minutes every time we ran the model when using those advanced time controls and allowing HEC RAS the ability to change the time interval based on that current number. All right. So that was it for this support video. What we did was we identified how to view the Courant number when running the model in plots like this one right here. And then we went to the computation time interval and changed that to different values, as well as let HEC-RAS determine that value based on the Courant number.